Howdy folks, welcome back to the channel. So this is a bit of a different video today. I have been hard at work that's a lie. I have been painting and I have a few videos in the pipeline. I was working on an orc scheme, which I finished the tester for that I was shooting all the footage on, but I have yet to finish the rest of the squad and I want to be able to put it all together, so the video's being delayed because of a few models not even really related to the main point of it, again. In any case, right now we are going to be talking about something not related to painting, but tangentially related to the Warhammer hobby as a whole, and that is dice rolling and math. Don't click off the video, it's not as scary as it sounds. So today I was reheating some chili for lunch when I was browsing XKCD, as I do sometimes, and I came across this particular comic. This is XKCD 3015. I'm certain that all of you know what XKCD is. If you somehow don't, I will put the link in the description. But anyway, I think it's fairly self-explanatory. This person wants to roll a weird probability, and the DM at the table comes up with a sort of ad hoc solution to accommodate it. And it's a funny little comic, but I actually went and tried to check it myself to make sure that it worked. And it is correct. I actually made a minor arithmetic error, which is kind of interesting, and we'll talk about it later, why I made that, but it is correct after I realized I was off by 3. But it brings up an interesting point that I see some people talking about with Warhammer, and that is specifically dice rolling and knowing the probability of certain dice rolls, especially 2d6 for a charge. What's the chance of, 9 up for a charge, or 6 or below for leadership, or whatever you're looking at. So I wanted to share a method that I actually use to calculate probabilities for dice on the fly, and also show how I was able to check this comic pretty quickly and in my head, albeit with a minor error, so maybe take that with a grain of salt. Alright, here we are in good old LibreOffice, because I don't have Excel. I apologize if my voice is a little bit rough, I'm starting to get sick. So, what I have here is a simple table representing the results of rolling 2d6. Very common thing you want to know in Warhammer. What are the chances of making, let's do a 9-inch charge. So what are the chances of getting greater than or equal to 9 on 2d6? So what I have here is 1 through 6 on these rows and columns, and the sums of these digits on the inside. And we have 36 possible outcomes here. So if I want to find out, again, 9-inch charge, I'm just going to count how many are 9 or higher. So we got 6, 7, 8, 9, 10. So that's 10 out of 36, which is the same as 5 out of 18. And in percentage chance, this is about 27%, 28% if you're rounding. Let's do another one. Let's do 6 or under. So let's do less than or equal to 6 on 2d6. And we're just going to count. We got 8 here, 9, 10, 11, 12, 13, 14, 15. So we're going to have 15 out of 36, which is 42% about. So there's an interesting pattern here. As you're looking at this right now, you're probably thinking, hey, this is stupid. I'm not going to, imagine this whole chart in my head every time I want to know a simple probability. But you don't have to imagine the whole chart. That's the wonderful thing about it. So as you can see here, because of the way that this works, we're adding up these diagonals. If I want to know a 10 up, maybe, I'm doing 1 plus 2 plus 3. I'm taking an extra diagonal each time. So I don't need to know, you know, what is, oh my god, this is 9, and then this is 2, and then this is 3, and then this is 1. I can just go 8 on a 2d6. It's 12, 11, 10, 9, 8. 5 diagonals. So I'm going to do 1 plus 2 plus 3 plus 4 plus 5, which is 21. So an 8 up is going to be 21 out of 36, or 7 out of 12. So I don't need to do this full calculation every time, as long as I know the sums of these first few numbers. These show up in all sorts of places in math. They're called the binomial coefficients, Pascal's triangles, another way you might see them. They're super, super important, and it's a really easy thing to just know what's 1 plus 2 plus 3 plus 4 plus 5. And it's just like, okay, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus... it goes on and on, you know. And I'm not saying that everyone should have these memorized, but I'm saying that it's not, you know, a super difficult thing to have. Another interesting facet of this is that you don't need to know, if I want to do, you know, what's the chance of a 4-up, I don't need to go, oh, okay, it's 1 plus 2 plus 3 plus 4 plus 5, so plus 6. So maybe I've got all the way up here, but then, oh no, I can't just add 7 and get 28. I need to shrink this back down, so then I add 5 again, and then, oh no, that's 21 to 26 and all that. You don't need to do that. The chances of getting a 4 up are the same as the chances of getting a 3 down, a 3 or less. So if I want to know what's the chances of getting all of this, all I need to calculate are the chances of getting this. Oh. So all I need to do is I need to do 1, 2, 3. So, and then I just take the complement under 36. So chances of getting a 4 up, well, the chances of not getting it are 3 out of 36. So getting a 4 up is 33 out of 36. It's a really simple way of doing it that genuinely, if you practice this enough, you will get much, much better at it. And it doesn't come up that often, but I can just go, oh, okay, what are the chances of getting 9 on 2d6? 10 out of 36, I calculate that real quick. Okay, it's a little less than a third. And it just helps to be able to visualize that. Alright, so now we have covered the basic grid for 2d6, and this is a pretty easy thing that you can apply to Warhammer, and you get some practice with this, you will be able to do those percentages. Well, probably not the percentages. I can't do the percentages. I know that 1/6 is 16.6, and that's the only percentage that I actually know. But you can know it out of 36 pretty easily, and I know that 10 out of 36, well, 12 out of 36 is a third, so I'm like, okay, that's a little less than a third. You can be able to do that easily. I guarantee you, you can do this with a little bit of practice. This is not some crazy esoteric thing. Now, we're going to move on to 3d6 so that we can actually tackle the XKCD problem. Before we do that, though, we're going to have 10 arrows, 5 cursed. This is the original problem that we've been given. We have 10 arrows in our quiver, 5 of them are cursed. We're going to pick 2 of them. We want to know what's the chance of not getting a cursed one. Let me double check to make sure that is the statement. Yes, it is. Looking to fire them, hoping I didn't grab one of the 5 cursed ones. Did I? 16 or better. Yeah, okay. So, what's the actual chance? So, not rolling this on D&D dice, what's just the actual chance of not getting a cursed arrow? So, I did learn about this wonderful thing called the XKCD Explained Wiki, which has an explanation for some of this on it. They don't do the grid, but they do have a different explanation of it. And they do it in a more convoluted way than is strictly necessary, but we're going to do it both ways. First way. I'm going to pick an arrow out of 10. I have 10 arrows, half of them are cursed. What is the chance that I get a cursed arrow? Or what is the chance that I don't get a cursed arrow? Well, okay. I know that it's just a 1/2 chance. Oh, goodness gracious me. Let's move into a larger cell. I spent some time setting this up so it would look pretty. First arrow. 0.5 chance not to be cursed. Actually, 1/2 chance. Which is pretty, makes sense. 10 arrows, 5 of them are cursed. Picking one of them at random, what's the chance it's going to be cursed? Well, okay, I got a 50-50 chance. Now, the second arrow. I have selected one. So right now I have 9 arrows, 5 cursed. I have taken one of my non-cursed arrows away. There is a larger proportion of cursed arrows to non-cursed arrows at this point. It's no longer 50-50. At this instant, I have a 5 out of 9 chance to get a cursed arrow, which means that I have a 4 out of 9 chance not to be cursed. Right? So, pretty simple. These are, well, okay, strictly speaking, they're not independent because one has to come after the other. But in this case, the first and the second arrow don't affect each other because we have taken the effect into account with the second arrow. So the overall chance of not getting a cursed arrow is just multiplying the two of them together. So that's going to be 1/2 times 4/9, which is going to be 2/9, which is 22.2% chance. Okay, that's wonderful. This is the chance that I don't get a cursed arrow. The second way of doing it is... oh my goodness. The second way of doing it is to actually count the number of ways that I can pick, the number of outcomes in which I pick all non-cursed arrows and divide it by the total number of ways I can pick the arrows. This is the way that the XKCD wiki actually solves this problem. I'm going to briefly go over this. The number of ways in which I can pick the non-cursed arrows, well, there's 5 non-cursed arrows, so I'm going to pick the first one. There's 5 options to do that. I have 4 non-cursed arrows left. There's then 4 options to do that. So there are 20 ways total in which I can pick non-cursed arrows. If I just have 5 non-cursed arrows laid out in front of me, pick 2 of them at random, 20 different ways I can do that. Then I'm going to divide it by the total number of ways to pick all of the arrows. I'm not making I'm not differentiating between them. That's just going to be 10, and then 9 for similar reasons, just picking 2 of them at random. So that's 90. That is not a minus, that is an equals. So then 20 over 90 is clearly 2/9. This is the way that XKCD does it, or the wiki at least, whoever, I don't think Randall actually runs that. But I think that this way is probably more natural and is the way that you were likely taught in school. So right now we have a 2d6 grid. This is the same as the one we were just doing. However, this is not a 2d6 grid, this is actually a 3d6 cube. So this is the value of the third die. This is what the bottom layer of the cube looks like. These are the results that we can get if one of our die, or if one of our dice is guaranteed to be 1. We can get 3 through 13. If one of the dice we know is going to be 2, we can get 4 through 14. If one of them is going to be 6, we can get 8 through 18. This is essentially a cube, and instead of just taking, oh, I'm cutting across this corner to find, the chances of getting a 16 up, instead of just cutting across this corner, now I need to account for each layer. So that was 1 plus 2 plus 3 is 6 on the first layer. This is 3 on the second layer. This is just 1 on the first layer, or 1 on the third from the top layer. And then as we go lower, we see that it's impossible to get 16. So if we wanted to get a 16 on 3d6, it's going to be 6 plus 3 plus 1, which is, of course, 10. and we are dividing out of 6 cubed now, because again we have 3d6, there's 6 times 6 times 6 possible outcomes, so we're dividing out of 216, because that is that. Now, it seems like getting a 16 or higher on 3d6, like the comic says, is pretty tough. We want to be able to get, 22% out of this, but if we actually do, what do we have? We had 10 out of 216. That's very far from 22%. However, we have a handicap. We have this D4. The D4 is going to make it easier to get 16. Right now, there's only 6 options that will give us 16. But if we add 1 to them, now all of a sudden we have 10 options. If we add a 2, now we have 15. If we add a 3, we have full 21. And if we add 4, we'll get to that. That's where my error came in. But let's just start to fill out this table right here. So we're going to go through this cube. Let's say that we have D4 is equal to 1. So on the top here, we're going to have 6, 7, 8, 9, 10. We're going to have 10 ways that we can get 16 or higher, given that the D4 is 1 and the third D6 is 6. If we go down a layer, now we're going to have 4, 6. We go down a layer, we're going to have 3. We go down a layer, we're going to have 1. And then if we go all the way down to 2, as you can see, it's impossible to get 6 in there. You might notice a pattern here. This is the same as it is just by adding diagonals. This is 1, 2 makes 3, 3 makes 6, 4 makes 10. It's the same pattern. If we go up to a D4, and then we're going to go back up to 6, okay, how can we get 16 up here? 9, 10, 11, 12, 13, 14, 15. Interesting. We've added 5 to our previous one. We're going to drop down to level 5. They're going to get 6, 7, 8, 9, 10. Okay, we're just repeating the same pattern that we already did down here, and we can check and make sure it's right. If we go down to 4, yeah, okay, that's 6. If we go down to 3, okay, that's 3. We're getting the same pattern. All that we're doing by adding the D4 is essentially just adding on 1 to each of these rows. And we can do the same thing with the D4 equal to 3. I'm not going to waste your time here. Again, this is 21, 15, 10, 6, 3, 1. Okay, seems pretty straightforward so far. Now we're going to get to 4. And as you can see here, this is actually where I found my problem. When I was doing this, I was just trying to envision this in my head, and I overcounted by 3, and I did it in 2 places here for the D4 equaling 4, basically. So if we count, we're going to find 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. This is not 21 plus 7, the eagle-eyed among you might notice. That would be 28. I ended up overcounting by 2 because I forgot that this and this are not in the square anymore. So we have to cut them off. And then we're going to follow a similar pattern down here. Again, we can check and make sure that this is actually correct. Like if we go down to 2, yeah, okay, that's going to be 6. We go down to 1, that's just going to be 3. And then I also tacked on another 1 down here, continuing this diagonal mentally when I was doing it. So I ended up counting an extra 2 here because I counted this as 26 or 28 instead of 26, and I added on another 1. That's not what you should do. But in any case, we filled out this whole table, and we're just gonna, sum this all up. Okay, if the D4 is equal to 1, then we have 20 ways out of however many to do this. If the D4 is equal to 2, we have 35 ways. That's what we're doing here. And then if we sum all of these up, we're going to find, wrong drop down, we're going to find 192 ways of getting these results? Well, that's 192 out of what? Well, so we're going to have 6 by 6 by 6 options. Let me put an equal sign. We're going to have 6 by 6 by 6 options for the 3d6, of course. And we're also going to have 4 options for the d4. We're going to have 864 options in total for how we can actually do this. Because again, a cube, 6 by 6 by 6, and then the extra handicap of the 4d4. 4 for the d4. And then if we calculate the percentage of 192 over 864, it's 22.2, the same as the actual percentage. So yes, Randall was right. This is, in fact, this is an accurate representation of rolling 2 9s at the table, even if it is a bit cumbersome. Because obviously this is just 2 over 9, 192 over 864 is just, what is that, 96 times, 96, because we have the, 16 times 6, because if you just take the 2 3s out. Okay, yes, so he's correct, and I know he's correct because I did this earlier when I was writing this down, because I was trying to find out where I had gone wrong. I had counted 195, and I actually looked it up on the XKCD wiki because I was curious, and because I was like, oh, that's a pretty close approximation, but I wonder if you could do better. And I just looked up XKCD 3015, and I found out that I was wrong, and I ended up having to write it down to figure it out. But I know now. What was I saying? Yes, that's a really cumbersome way to do it. We are able to do this using the grid, and it's fine. It's pretty simple. But it's just, why would you roll 3d6 plus 1d4 to calculate it? There's got to be easier ways to do that at the table. And in fact, there are. The way that I would most readily think of would be to roll 2d6 and add them together, like we were doing with the charges earlier. This is because if I were the GM here, and I had calculated 2 over 9 as my probability, I would have immediately thought, okay, 9, let's turn that into 36 somehow. And I'm like, okay, 6 by 6 is 36. All I need to do is find a scheme of adding things together such that I get 8 items out of 36, because 2 over 9 is 8 over 36. So the way that I would do this, if I was running this, would be roll 2d6, add them together. If you get either an 8 or a 10, because 1, 2, 3, 4, 5, 6, 7, 8, that adds up to 8 out of 36, and that is probably the simplest way I can think of to do it. Again, because it is complementary, you could also do roll 2d6. If you get a 4 or a 6, you can do it. Or, or 4 and 8, or 6 and 10, or whatever. It does not matter. The other way, there are a few other ways. The wiki had a few of these on here. One of them is also to multiply by 2d6. So roll 2d6, multiply the results. Obviously, this is a very different table. We don't get nice diagonal lines off here. We get more of an arc, like we get 12 in an arc here. It builds out like that. If we select 8, well, 20 or higher is 8 out of 36. So roll 2d6, multiply them together. If you get 20 or higher, that also counts as a pass. That's way easier to do as well. Another cute little way to do it is, this is D&D, so you have other dice besides D6. You don't get that in Warhammer. So roll a D12 and a D3, and then if you get a 21 or higher, that also counts. This is a little bit cumbersome though, because you would have to roll a D6, truncate it to make it into a D3. At that point, you might as well just do the 2d6 multiplication strategy. But these are some easier ways to do it. The 3d6 plus 1d4 was, of course, exaggerated for effect in the comic. But the point is, I wanted to show you folks an easy way to calculate dice probabilities. Ooh, is it going to crash? Is it going to crash? Are we going to find out? I wanted to show an easy way to calculate ways of rolling 2d6 and also ramble on about some other stronger applications of this idea. So I hope you enjoyed this. Maybe I'll have to edit this and put a lot of timestamps to make this even somewhat useful as a tutorial. But yeah, hopefully you can use this in your next Warhammer game. Let me know in the comments if you do. And please stay tuned for actual painting videos coming soon. I swear I'll finish up my orcs. I'm working on some kill teams. I will get that out at some point. Probably after I recover from my sickness, which is coming on right now. Anyway, have a good one. See you in the next video.